Alright, guys, right here, a system of equation is a situation where two or more equations have two or more variables. Solution of a system of equation, algebraically, an x and a y value that make both equations true, graphically, where two lines intersect. The goal of solving system of equations is to find values for both variables that make both equations true. There are three methods: graphing, substitution, and elimination. Today we'll be talking more about graphing. Graph each line on the same coordinate plane. Be sure to draw each line accurately and neatly. You can graph the intercepts or the m and b, or the slope and y-intercept. Identify the solution of the equations if there is one. Write the solution as an ordered pair x and y. Check the solution by substituting the values into both equations. For example, here's how to check it. If we have the equation y equals 2x plus 2 and 4x plus y equals 8, the solution is 1, 4. So I just take 1 and 4, which is x and y, and I plug them in for x and y of my equations, and if you notice that they're both true. Alright, so here's an example of graphing. I got y equals 2x minus 4, shows that my m and my b here, and y equals negative x minus 1. Which my m is negative 1, my b is negative 1 as well. So I graph these. I start at negative 4. I go up 2 over 1, up 2 over 1, down 2 over 1. Draw my line right here. Alright, and then if I do the other one, start at negative 1. I go down 1 over 1, down 1 over 1. Notice that my ordered pair that is in common is 1, negative 2. Also, I check these right here. Notice that negative 2 equals negative 2, and then negative 2 equals negative 2. Alright, my next example is 4x minus 8 equals 24. Right here I'm finding x-intercept, so I'll make y 0. So I get 0, I got 4x equals 24 divided by 4, x equals 6. So my x-intercept here is 6, 0. And so I put that point, I put that point right here. Now, also notice that my, I gotta find my y-intercept, so I'll make x 0, and I got negative 8, y equals 24, divided by negative 8, I get y equals negative 3. So my y-intercept here is 0, negative 3, so I mark that point, I draw my line. Now the other one, we could find x and y-intercepts here. I just changed it to slope-intercept form, so I subtracted x, I got y equals negative x plus 4. My m is negative 1. My b is 4. So I start at 4, go down 1 over 1, down 1 over 1, down 1 over 1, until I notice that I meet right here at 5, negative 1. And if you were to plug those in, you should get the same equal on both sides of your equation. Alright. Look at the next set of problems. Now y equals 6 minus x. I changed that to equal y equals negative x plus 6. Now I also have y equals x. So we look right here. And I'm going to graph both of these. I graph y equals negative x plus 6. I go down 1 over 1, start at 6, down 1 over 1 all the way down. And you really want to make it all the way across your graph because you're not really sure if what point the other line is going to meet it. Like if you just only do 3 points, you don't know if the other line is going to cross at those 3 points. So you need to make it all the way across your graph. And then we do y equals x. So we start at 0, we go up 1 over 1, up 1 over 1, up 1 over 1. Because we know that our m here is 1 and our b is going to be 0, 0. Alright, and we notice we cross right here at 3, 3, and I checked it down here at the bottom. And I did 3, put in 3 for y, and I put in 3 for x. 6 minus 3 is 3, 3 equals 3. If I plug it into y equals x, 3 also equals 3. Alright, we do the next one. Put my y there. You can make it y equals 3x. plus 1 by the reflexive property. And then we can graph it. So we graph this one, start at 1, we go up 3 over 1, up 3 over 1, down 3 over 1. We start the next one at 0, 0, we go down 1 over 1, up 1 over 1, and we cross at negative 1/4, 1/4. Now, this one will be harder to see if you were just graphing it. You couldn't really make this up. So the other methods would come more in handy as far as solving this one, such as substitution would be the best logical way to solve this one. Alright, number 3. First thing I did was I put x plus y into slope-intercept form. I got y equals negative x minus 3. So I start at negative 3, I go down 1 over 1, up 1 over 1, draw my line. Make sure you keep going. See, I went all the way across my graph here. And then I did y equals negative 2x minus 1. And I started negative 1. I go down 2 over 1, down 2 over 1. Notice I meet right here at 2, negative 5. And if I was to plug these in, so I'll say negative 5 equals negative 2 times 2 minus 1 be negative 4 minus 1, which gives me negative 5 equals negative 5. So yes, it works for the first equation. We can also check it for the second one. So I got 2 plus a negative 5 equals negative 3. 2 minus 5 is negative 3 equals negative 3. Yes, it works for both. Alright, now you're going to complete some practice in class.